Hello, I'm Dana Badawi and I'm going to be your physics teacher in this course. So, I'm going to give you in this class, in the first class, a comprehensive overview of IGCSE 0 about it, okay? Now, making measurements. Making measurements, this section or this unit, it's the first unit of your in your chapters or in your book. Okay, this unit, it's all about measuring some quantities or certain quantities such as the length, the volume, the density, and the time using some measurements. Okay. Now, motion. In this section or in this unit, you're going to understand or distinguish between the speed and velocity. You're going to distinguish between displacement and distance, and you're going to distinguish or understanding the acceleration, calculate all these quantities, and also understanding the graphs of the distance versus time, and distance and speed versus time, and velocity versus time, acceleration versus time. Okay, now forces in this chapter, which is the third chapter, forces and motion under energy storing methods or storage methods, and we're going introduction to one-dimensional motion. One-dimensional motion. Okay, so this introduction is going to be like introduction for chapter 2. Okay, so introduction to one-dimensional motion. We have objectives for this class. Okay, we conclude them in 8 points, which are they: SI units, sign convention, understanding the difference between vector and scalar. Okay, and distinguish between position, distance, and displacement. And number 5, distinguish between speed and velocity. And 6, understanding the acceleration. And then point 7, we're going to understand distance versus time, acceleration versus time, and velocity versus time. Okay, graphs. Okay, and we're going to do a conclusion, a very small conclusion. Okay, let's get started. Okay, SI units. Okay. SI units is an international system of measurements that are used universally in technical and scientific researches to avoid the confusion with the units. The reason behind this unit, okay, having a standard unit system is important because it helps the entire world to understand the measurements in one set of unit systems. So, according to the scientists and the physicists, okay, they do a conference, and in this conference they decided to unite the units for each and every single physical quantity or physics quantity. So, for example, we have the length. Now, the length, its unit is meters, okay? Its unit is meters. And we all know that there's lots of units for length. We have centimeter, we have decimeter, we have kilometer, and we have meter. But the scientists decide to take the the meter, avoid any confusion happening between. So now I want to give you just a hint or like an example. If I told you, okay, if I told you that there is a car, I know that maybe the things is not clear yet, but in the class, you're going to understand everything. So if I told you that there is a car, its velocity equals to 50 kilometer per hour. Now, don't focus, please, in this section, don't focus on the velocity and what the meaning of velocity, because in a minute we're going to understand everything. Okay, so velocity equals to 50 kilometers per hour. Now look to the unit of the velocity. The unit it's equals to kilometer per hour. So how can I convert it to the standard units? The standard units for the length, okay, and the time, it's equals to the standard unit for kilometer and hours, it's equals to m per s, which is the meter per second. Okay, so how can I convert it? How can I convert this unit to m per s or meter per second? Now, first of all, first step 1, we have steps. So step 1, we need to memorize or understand that the kilometer it just equals to 1,000 meters, or in other words, it is equals to 10 to the power 3, okay, meters, okay? Remember the prefixes? The kilo, it's equals to 10 to the power 3 meter. Remember the prefixes, sorry. So go back to the schedule or go back to the table, okay, in the previous slides. You're going to find that the kilometer equals to 10 to the power 3 meters, okay? Okay. So I have to know this and memorize it. Another fact I have it, that the hour, it is equals to 60 minutes, okay? And the 1 minute or the minute and the minute 1. To find that the kilometer equals to the 10 to the power 3 meters, okay? Okay. So I have this, I have to know this and memorize it. Another fact I have it, that the hour, it is equals to 60 minutes, okay? And the 1 minute, or the minute, and the minute, 1 minute, it's equals to 60 seconds, okay? So how can I manipulate these things to convert kilometers per hour to ms? So first step, I have those facts, okay? The second step, I have to do the following. Now, the step 2 is going to be the ratio and proportion. So now, if I have the kilometers, okay, or 1 kilometer is going to be equal to 1,000 meters. Now, the 50 kilometer is going to be equal to what? 50 kilometer is going to be equal to what? Here I have a question marks because I don't know, and I maybe put it as x as an unknown, okay? And I'm going to do the cross multiplication. Okay, I'm going to find that 1 kilometer multiplied by x is going to be equal to 50 kilometer multiplied by 1,000 meter. Okay, so I'm going to divide 1 kilometer over 1 kilometer. They will cancel each other, and then I'm going to find that over 1 kilometer is going to be equal to what? Kilometer with kilometer is going to cancel each other, and the x is going to be equal to what? It's going to be equal to 5 or 50,000 meters. So now I convert the kilometer to meter. Okay. So now I'm going to do that, the same thing for the time. Okay, Okay. So let's do that for the time. Okay. So step number 2. Now for 1 hour. So I'm going to say 1 hour is going to be equal to 60 minutes. Okay. Now I have here 1 hour. It's almost 1 hour. Okay, because 50 kilometers per 1 hour. This I can read it as following. 50 kilometers per 1 hour. So 1 hour is equal to 60 meters. So definitely the 1 hour equals to what? Definitely you have to catch it quickly. So it's going to be equal to cross product. So it's going to be equal to 1 multiplied by 60. Okay, 1 multiplied by 60. Okay, equals to 1 hour multiplied by x. Okay, 1 hour and 6 minutes. You have to mention or to put the units in beside each number. Okay, so I'm going to divide here over 1 h over 1 h, because I want to get rid of all the things or all the numbers around the unknown. It is our mathematics rule. Okay. So I'm going to find that hour with hour is going to cancel each other. So the x is going to be equal to 60 minutes, or I can say that 1 hour equals 6 minutes quickly. Okay. So now I have the 60 minutes, or for example, let's do it again to convert the minutes to seconds. Okay. So I have 1 minute is going to be equal to 60 seconds. Okay. What about the 60 minutes? How many seconds it will contain? We'll put x and question marks and do the cross product, and then it's going to be equal to what? It's going to be equal to 60 minutes multiplied by 60 seconds. Okay, and I have 1 minute multiplied by x. So I'm going to divide this over 1 minute because I want to get rid of all the values or all the numbers, okay, beside or around the x. Okay, so minutes with minutes cancel each other, and over 1 minute I'm going to have minute with minutes going to cancel each other, and 60 multiplied by 60 is going to be equal to, so x here is going to be equal to 3,600 seconds. So now with these steps I convert the 50 kilometer hour to give the west minus sign or negative sign, and to the east meter or the coordinate system that you all know, which is the x-axis and the y-axis. Okay, so here we have x positive on the right, and we have x negative, and we have y positive and y negative. So to make it easy for you, my left hand, it's always going to be the west. My left hand, it's always going to be the west. Okay, so I have my left, or left hand with the west, and my left hand, assume that I am on the origin, on the origin here. Okay, assume that I am standing at the origin. Okay, my left hand is going to be the west, and I'm going to give it a minus or negative sign, okay, because it's going to rotate it or its position is going to be on the x minus or x negative, okay, and I have my right hand is going to be on the right side, which is always or also the what? The east, okay, and I'm going to give it a positive sign according to the coordinate system. So assume that I am standing or you are standing in the middle of the coordinate system, and I'm going to find that up, which is positive y, up my head, okay, my head up is going to be the positive y, and okay, down is going to be negative y, and it is south and north, okay. So to memorize this, okay, to keep this in your mind, okay, and have it easily, okay, you have to plot the coordinate system, and mention or put the directions, the north, the south, the west, and the east, with your right hand, your left hand, your right hand, your legs to down and up your head, okay? Okay. In this slide, I want you to understand just this thing, okay? And through the course and in the next slides or in the next videos, you're going to understand why I do this. And I mentioned that vector, when I have a vector quantity, I have to mention those things, or I have to put positive or negative according to its direction. Now, in a minute, you're going to understand what vector and the scalar is. Scalars and vectors. Now, I want you to understand that the scalars are quantities with magnitude only. Okay? So, all of these quantities include a magnitude, size. I have magnitude. I have a value for them, but I have no direction. So that is the scalar S. That is the scalar. Okay, the scalar is a quantity with magnitude only. So I have just a magnitude for it. I have the value for it, and I have no direction. There's no direction in it. Okay, no direction. So, for example, we have the mass. Mass. Okay, for example, a girl or me, and I'm Dara Badawi. I weighted 50 kilograms. Okay. Is it possible to say that I have 50, or I am weighted 50 kilograms direction east, or direction west, or direction north, or positive or negative 50 kilograms? Is it sensible, or does it make sense to say this? It's not right. Okay. And let's talk about time. Time is also an example. The time is also an example of what? Of a scalar quantity. So the time I have have you ever heard that the clock equals, or the clock is 12 p.m. negative, or 12 in the direction of east or west? I'm talking about the clock. Is that right? It's not right. So the scalar, it's always the scalar is all about the magnitude only and no direction. I don't have to mention the direction because there is no direction for this quantity. Okay. Let's go to the vectors. Now, vectors are quantities with magnitude and direction. Okay. Magnitude and direction. So, if you remember in the previous slides, I told you about the sign convention. So the sign convention told me, okay, to put for the left minus, for the right positive, for my head up positive, for my legs negative. Okay. So according to that, I have to mention the direction. So all of these quantities include magnitude and direction. So if I have a displacement, for example, I have position, displacement, velocity, and acceleration. You might not understand what position, displacement, velocity, and acceleration are or is. Okay, but in a few minutes, we're going to catch each one of them and illustrate them separately. Okay, so for example, let's say we could say actually if the car's velocity is equals to maybe 50, let's describe it as a 50 meter per second, okay? I can say that the car is directly, or it is moving in the direction of east or west, okay, or north or south. And I can represent the E and the W, okay, which is represent for, or stands for west, and E stands for east. I can put, instead of east, I could put positive, or instead of west, I could put negative, okay? That's what I want to tell you. In the previous slides, we talked about the sign convention. So the sign convention, I use it only for the vectors quantity, okay?